Imagine standing outside under a perfectly clear, sunny sky. You ask your smart assistant, "Hey Google, what's the weather like?" And it says, "It's raining." No clouds, no water, just confident robotic nonsense. And when you ask it why, it doubles down. Weather data suggests 90% precipitation. No hesitation, no apology. Just certainty in completely flawed data. In this video, we're diving into one of the biggest blind spots in modern AI, why it often gets things wrong, and why a new approach called NeuroSymbolic AI might be the fix we've been waiting for. Most AI today is powered by neural networks. Imagine you want to teach a machine to recognize a dog in a photo. The photo is just pixels, tiny dots of color. Neural networks take these raw pixels as input, convert them into numbers, and start searching for patterns. The input layer is where this raw data enters the network. It's like the machine's sensory organ, turning images, text, or sounds into a number format so it can process it. Early hidden layers focus on very basic features. If the input is an image, these layers might identify things like edges, textures, or colors. If it's numbers or text, the layers might detect patterns like rising trends, clusters, or associations between terms. As the data moves forward, later layers build on top of that basic information. They start piecing together more complex structures, like identifying that certain shapes arranged in a certain way might mean whiskers or paws. Then comes the output layer. This final layer doesn't try to describe the image in words, it gives you confidence scores. These numbers show how confident the network is that the input belongs to each category it was trained to recognize. So in our case, the network might say, "I'm 89% sure this is a dog, 9% a wolf, and 2% a rabbit." It doesn't know anything, it's just matching patterns and guessing based on probability. So far, we've seen how neural networks process data and make predictions. They power facial recognition, language translation, voice assistance, spam filters, and even the tools behind image generation and deepfakes. And to be fair, they work pretty well, especially when they're working with data that looks similar to what they were trained on. What's exciting though is how accessible this technology has become. You don't need a PhD to start building neural networks. Tools like TensorFlow and PyTorch, both Python based, have completely changed the game. As someone who's worked on Python projects before, I can tell you, it feels good to write code that's this powerful and still reads like plain English. But let's slow down for a moment because there are some important limitations to be aware of. First off, these models need tons of data. Say you want to build an image classifier that distinguishes between different dog breeds. You're not just tossing in a few pictures, you need hundreds or even thousands of examples for each breed. That means more training time, more memory, and longer response times. Not only that, but when a model has to go through so many steps to arrive at a prediction, it introduces more points of failure. A mistake early in the process, like misreading the shape of an ear or the texture of fur, can ripple through the entire chain and completely throw off the final result. And here's the kicker: neural networks are black box models. That means when something goes wrong, you can't really crack them open and find the issue. They don't explain themselves. You just get an answer and confidence scores, but not the logic behind it. So if your model makes a wrong prediction, you often have no idea why. No debug logs, no step by step reasoning, just silence. If neural networks are like intuitive guessers, powerful but mysterious, then symbolic AI is the opposite. It doesn't guess, it reasons. Instead of learning from huge piles of data, symbolic AI uses human readable symbols to represent concepts like cat, animal, or rain. These aren't just labels, they're part of a structured knowledge base that stores facts and relationships. This knowledge base is like a digital library of common sense. For example, the system might know that a cat is an animal or soccer is a sport. Pretty simple. To make connections, symbolic AI uses logical rules which are mostly good old fashioned if then statements. For instance, if X is a cat, then X has fur. If it's raining, then the ground is wet. These rules help the system to reason about the world. Let's say the system knows that Tom is a cat and it has a rule that says if X is a cat, then X has fur. It can now logically conclude that Tom has fur. This is called deterministic reasoning. Same facts, same rules, same outcome every time. And here's the best part: everything is explainable. Every conclusion can be traced back step by step. This makes symbolic AI especially good for domains like medicine or law, where you really need to know why a system made a decision. What I love about symbolic systems is how modular they are. You can add new knowledge or rules without retraining the whole model. It's kind of like how we learn. When we pick up calculus, we don't start over from basic arithmetic. We build on what we already know. This kind of structure is really useful in high stakes tasks, like making sure a medical AI never recommends a dangerous drug combo. And because it doesn't need to see thousands of examples to learn a concept, symbolic AI is actually data efficient. But symbolic AI has a weakness. It can't learn from raw data the way neural networks can. If it hasn't seen a rule before, it just fails. This is honestly what frustrates me the most. Symbolic AI doesn't improvise. Imagine hanging a picture and realizing you don't have a hammer. Most people would grab a shoe or a book and make it work. A symbolic AI, it would just freeze. No rule equals no action. This rigidity becomes a real problem with messy, unpredictable inputs like human language or blurry images. Neural networks can handle this because they can generalize. Symbolic AI, not so much. And while deep learning has entire ecosystems of tools and frameworks like PyTorch and TensorFlow, symbolic AI hasn't gotten the same developer love. That makes it harder to build with, even if it's very precise. So while symbolic AI is powerful when rules are clear and decisions need to be traceable, it struggles when you throw it into the chaotic, unpredictable real world. Neural networks are great at handling patterns and trends. Symbolic AI excels at structure and logic. Alone, each has limits. But what if we didn't have to choose between pattern matching and reasoning? Here's where NeuroSymbolic AI comes in. This approach combines the pattern recognition strength of neural networks with the reasoning power of symbolic AI. The neural side processes raw data, images, sounds, text, turning messy inputs into structured, meaningful information. For example, a neural network analyzing a photo might detect objects like trees, cars, or people by scanning pixels and extracting features through multiple layers. It translates raw sensory input into numbers that represents what it sees. Once this processing is done, the neural network outputs these interpreted values into something closer to understandable concepts. Now, these values are handed off to the symbolic system. The symbolic AI uses its knowledge base filled with human readable symbols and facts. Using clear logical rules, it reasons about the neural network's findings. It checks, do the detected objects fit known categories? Are there contradictions? What conclusions logically follow from the data? This reasoning lets the AI choose the most consistent and explainable decision. Neurosymbolic AI aims to give machines that same combined power, learning from raw data plus reasoning with knowledge. Why does this matter? Because many AI mistakes happen when the systems rely only on pattern recognition or rigid logic. Imagine a self driving car detecting road signs. If a stop sign is obscured or vandalized, a pure neural network might misread it. But a neurosymbolic system could use reasoning to infer the sign's meaning based on the surroundings. In medicine, doctors want AI to explain diagnosis, not just guess. Symbolic reasoning provides these explanations, helping AI decisions become trustworthy. While neurosymbolic AI represents an exciting step forward, it's important to remember that it isn't a magical solution. Like any new technology, it comes with its own set of challenges. The biggest hurdle lies in the mismatch between how neural networks and symbolic AI systems operate. Neural networks excel at finding patterns, but struggle to explain their reasoning, while symbolic AI follows strict logical rules. Getting these two approaches to work together smoothly needs careful design, both technically and conceptually. Scaling these systems can also prove challenging. As problems grow more complex, maintaining the right balance between pattern recognition and logical reasoning becomes tricky. So, is it the ultimate answer to AI's limitations? Not yet, but I think it's a promising direction, one that moves us beyond the trade offs of the past and towards systems that are more capable and ultimately more useful in the real world. The journey won't be simple, but the destination, AI that truly understands what it's doing, is worth the effort. Thank you for watching, and be sure to check out our blog post to learn more about NeuroSymbolic AI.